In this video, we'll be talking about how to find our expected values for chi-squared goodness of fit. Now, the process itself is pretty straightforward. All we're going to be doing is taking our expected percentage and multiplying it by the total number, that is like our sample size. In order to see how this works, let's go ahead and look at an example. Here we're looking at SIDS, that is sudden infant death syndrome, and whether or not it's seasonal. In order to calculate our expected values, we need to understand what our null hypothesis is here, and because I'm trying to prove it's seasonal, my null hypothesis is going to be it's not seasonal. And if it's not seasonal, what that actually means is each month is equally likely. Now, within the sample, we had records of 400 deaths due to SIDS, and so what we need to start thinking about now is, well, what would we expect to happen? And so I'm going to go ahead and put together an expected column. Well, I know right off the bat that I have 4 categories here, and that is I have summer, I have spring, fall, and winter. And now if I have 400 total deaths, and I know each month is equally likely, then I would expect these deaths to be evenly split over these 4 months, which means, in reality, if I have 400 deaths, I would expect about 100 in the summer, 100 in the spring, 100 in the fall, and 100 in the winter. And I get this because I am taking, once again, my expected percentage, that is, I expect 1/4 or 0.25, 25%, and I am multiplying that by the total sample size, which is 400. So I'm putting 1/4 of each of those 400 in each category. This is how I calculate my expected value. Once again, expected percent times total. Let's go ahead and look at our example here. So in this example, we're going to be looking at inheritance of physical traits within plants, specifically their seeds. And we're going to try to show, do they fit or do they not fit a 9-30-3-1 inheritance? And what this is telling us here is that we'd expect 9 out of this group to be wrinkled and brown, 3 to be wrinkled and yellow, 3 to be smooth and brown, and 1 to be smooth and yellow. And this is out of, once again, a ratio here. Now, in our study, there were 1,250 seeds, and so what we need to do is we need to go ahead and, first off, list our null hypothesis. I'm assuming that they're fitting this 9-3-3-1 inheritance pattern. Once again, where there's 9 wrinkled brown, 3 wrinkled yellow, 3 smooth brown, and 3 smooth yellow per group. When I go to set up my expected values, I'm going to start by listing my categories. So my categories were, once again, wrinkled brown, wrinkled yellow, smooth brown, and smooth yellow. The next thing I'm going to do is I'm going to go ahead and calculate my expected value. To get this, I need to think about what this ratio means. I'm saying there should be 9 in the first, 3, 3, and 1. If I have a 9-3-3-1, that means the total number of seeds I have in this little ratio would be 16. Because if I have 9 plus 3 plus 3 plus 1, there's 16 total. And out of that 16 then, I know 9 of them should be wrinkled and brown. So the ratio for wrinkled and brown should be 9 out of 16. I can then calculate the ratio for wrinkled and yellow, and that would be, well, there should be 3 of those, because that's that second thing, divided by 16. And once again, I'm getting that 3 right here by looking at its placed in the ratio. I could do the same for the other ones. This should be 3 out of 16, and this should be 1 out of 16. To reinforce this, I'm getting the 16 by adding up the total number in this ratio. Well, if I want to calculate the expected number of wrinkled brown seeds then, all I'm going to do is I'm going to take that ratio. I mean, I could convert it to a decimal place, but then I might have to round it, lose some accuracy. So I'm just going to take it as written. I'm going to go ahead and use my total number of seeds here, 1,250. And for that 1,250, I'm going to multiply it by my expected percent, 9 out of 16. When I do this, I'm going to get a decimal, and to preserve accuracy, I'm going to go ahead and keep those decimal places. That is 703.125. In the future, we'll go ahead and round to 2 decimal places. For this example, I'm going to keep 3, once again, just for accuracy. For the next one, I'd multiply 1,250 by 3 over 16, because that's the ratio that goes with it. And when I do that, I'm going to get 234.375. When I do the one for smooth brown seeds, it's got the same ratio as wrinkled yellow, which means it's going to end up with the same number, 234.375. The final thing I'll do is go ahead and plug in the last one, which will be 1250 times 1 over 16, which will give me 78.125.